So let's set the window title. We can do that. Yes, we can. Okay, we'll do it that way. Set window title. Let's say this is called the MMO game. And of course, we have to tell it which window it is. And this is it. See if that still builds. So let's see. We know. So here we are. Let's see. Yeah, it actually built. I will just run it again and to see. Okay, it's MMO game. So now I can show it to you, I guess. Let's try that. Window capture the actual game. Let's see if that works, really. Let's see if that works. I think I have to run it so that it captures it. Just give me a second. Okay, it finds all kinds of stuff, but not my game. Okay, so that will be interesting how to show that to you. Ta-ta-ta. Let's see, how can we do that? This is not it. This is not it. So that's a bit of a bummer. How can we do that? Let's try something else. Let's actually try something else. Let's do game capture. So what is the window? Yeah, I mean here it sees it. Okay, that's actually okay. Yeah. So here we go. This is our game. And now we're running out of screen space, and I will just put it up here. Yeah, so it should go away now, and when we run it, you should be able to see it actually, or not. Why not? Why not? Okay, you just have to do it like this. But okay, yeah, that basically seems to work. Very good. Very good. Very good. So let's see. What next? Now we have a very basic screen running. Next thing I think we should do, like we're really kind of bootstrapping us now and try to have all the basic functionalities in place that we will need when really developing our game. Next thing is maybe that we want to render some text, and there is something that I'll just probably I will just quit this for now. There is a helper library from STL that does text rendering for us, and we will really just use that now. Because text rendering is really very important, because with text rendering we essentially can render debug output and so on and so on. In game we can, for example, have a frame counter and so on and so on. So that's really quite useful to have. Let's now see how to find that. The best way, I think it's called libstl text. Let's just see if we find that quickly. Yeah, that's it. A TrueType font library. So we will again download the MINGW version of that. Just download it. And then we will actually just open up the documentation. That's quite nice. We will just unpack it. I will do this in the background. Extract files to and then let's go back to our trusty Explorer here, where we have our project C++, libs, and here I have this stuff. We'll really just extract it here. Get rid of this. There again, it's the same principle. You have basically the runtime libraries, which we can already copy because we might need all of them anyway. I will just copy them. No, that's the wrong thing. Copy them to our game because we will need them in the runtime. And then we have again to include the path here because we will need to include some stuff. So we will just go to our build.bat file, and we will essentially, where's GWM? Okay, here we go. We will essentially just add a new library location here. So yeah, that should be doing it for that, and then we will just include SDL2. Let's look it up. What are we doing? One page HTML. That's the good one. That's the one I like. Okay, so this shows you how to install it, but we essentially just did it. We're not compiling it. Yeah, you need TTF in it. But does it show how to include stuff? Okay, that's what I was looking for. So we need SDL ttf.h. So let's actually see if it finds it, but I think we also need to use it, otherwise I think it won't really care, probably. But let's see. Include SDL.h. Yep, okay. That's okay. Yeah, I think there is now a bit of a problem here. Let's just see. So that also happened to me already sometimes. There was this problem. Pum. Yeah, let's see. So let's open that up. And then it says include STL.h, but this is actually STL2. Now let's see. That works. Begin code to the H. What is that? Where is that? Where should that be? Where is begin code? Let's have a look where that is. So now the fun starts. Yeah, okay, that's the same problem. So we essentially just patch this file. I mean, you don't see it now, I believe, but I can show you, of course. Just a second. Just a second. So, and what we're doing essentially is, and what I did is I just prefixed this. I mean, I don't know why they do this. It seems like this is not really like working together. I mean, it's supposed to work, but somehow they always miss these prefixes here. And yeah, I'm more the hands-on guy, so I will just kind of correct this here. And just remove that now. Let's see if that works again. I think I should put that up actually. So let's see what is happening here. Close code. Oh no. Okay. So that's the next problem. Where is close code? Close code is here. Same problem. I think then we're through. I think so. I think so. Yeah. Okay. At least we're building now. Still running. The game is still running, as you can see. Let's put the game always on top. So still running. Fine. Good. Let's actually do something. Let's just create it. Let's create the TTF, the true type rendering stuff after we have created the window. Let's just do that after that. Let's see how that works. I think that is not a problem at all. So, oops, let's see how that works. So if you say if TTF init smaller 0 or equals -1, doesn't matter. Yeah, we will just bail out and say, well, you know what? We will actually do this kind of right away before we actually even create the window. So we just don't waste resources. And if this doesn't work, well, we just bail out. Error while initializing TTF, still TTF, and then we just print out the error, then is TTF get error. So very similar to STL2. It's just like instead of STL, it says TTF. And that's all it does. Just quickly checking the chat. Okay, nothing there. Good. Not good, but okay. Okay, so this is it. And now actually we should get a linker error, but we will then solve that immediately. Let's just see. Yeah, so the linker returned an error status, so it doesn't find the symbol TTF in it. So we have not linked in the library where this function is actually there. So let's just do that. And let's just look it up. And this is the path that we want to use. So let's just see. I mean, that's really getting messy. I think I will spend some minutes to try to clean that up and to have that like in multiple lines, but whatever. So we will add that to our wonderful path. And then we also link to the library itself. We say TTF STL2 TTF. That's the name. Okay. Okay. What's the problem? Okay. Yes. I know the problem. That's just one big line. Oh, that's horrible. Sorry. STL TTF STL2 TTF. Okay. Let's see if that runs. Let's see if that builds. And then let's see if that runs. Sorry. Yep. Yeah, it does. Okay, you don't see it. I just closed it down. Didn't even show you. But it basically built. I mean, kind of doing nothing, but whatever. So just took a grab. Took a small piece of water. So okay. So let's try to render something, shall we? Now we will actually need to learn quite some things along the way. We will now need to play around with textures and so-called surfaces, but we will do that. That's fine. We will come to that. First thing we need to do is to really. So goal is that we write something on the screen, like I don't know, like Hello MMO game, but like on the screen, like as textures, as sprites. Yeah, that's a goal. So let's see. Let's create our TTF font. Let's call this the default font, or let's maybe call it like font default. And just initialize it right away. That's good practice anyway. Open font. And yeah, so we will just give it a font. And we will really just download a nice font here now. We'll just do that. I think it's called 1000 fonts or something. These are free fonts, 1001 free fonts. So just grab the next best. Well, it doesn't really matter. I'm always overwhelmed when something like that shows up. Trash, but what is that? What is trash? Okay. Yeah, that's actually quite nice. I think that's actually quite nice. Yeah, why not? Let's download this. I guess it's okay. I think it's personal use here. I'm not really making something commercial here. So I will just unzip this somewhere where I can show you a bit. Okay, that's just the OTF. See if that works actually. Let's see. Let's just put it into our actual game folder, which you see here, or you don't see it, but I will show you in a second. I will show you in a second. So here it is. It's called Funk Rocker OTF. I mean, I'm not sure if you really see the same thing as I do. I think we're still in the other. Yes. I think we have to change. Sorry, I was in the wrong place. So here it is. So here we have our GameX. You see that's what we just created. And here even your is the Funk Rocker OTF. So that's the thing from the 1000 fonts. Okay, well, that's the thing here that we just downloaded. Okay, let's see if it can actually load that. If that works, if that is really true type compatible. Let's see. If not, we will just try to find another font. It doesn't really matter what it is now. It's just like it's just an example. Okay. So and so what we say it's called, what was it? What was the name? Funkrocker.otf. Let's see if that actually works. And then we also just give it a size. Let's start with 20. So if we do not have a nice font, then again we will just bail out error while loading font. And you know this already. Get the error and we just return. So let's see if that works. No, it does not, because this is the font default. So sorry. Now you can see it again. At least it built. And okay, so we see there is error while loading font, couldn't open funkrocker.otf. So let's see now what the problem is. I'm really not completely sure if this is now the problem because of the OTF, but we can find it out quite easily. Let's see if we get another error if I write the wrong file name. Yeah, okay, that's a bit of a problem. So I'm not completely sure if that is really the case. I mean, let's see if we find something that is a TTF here. I will just have a quick look into that. Yeah, let's probably try that. Let's just try that instead. So just you see that I put this new font here. It's called grizzled font regular.ttf. Let's just try that out. I mean, the library says STL2 TTF and not STL OTF, so might be a reason for that. Couldn't open grizzled font regular.ttf. So that's now the question. It could be that this needs let's just try it out actually. Let's just give it a full path. Let's see if that works. Let's let's see if that works. Oops. So sorry for all the beeps. I know that's super annoying and there is a way to turn it off, but I think I will just do it like this. That should work. So let's see if that works or not. Yeah, that worked. Okay, so we have to give it the full path. There is a trick to actually that we don't have to do this. So you see the game came up. It runs. I mean, we don't do anything now with it, but it runs. Okay. Um, but just out of interest, no, let's stick with that font now. That's fine. Okay. So let's put this back up. Just that you saw it. Okay. So now it runs. It builds. Now it runs. Okay. So let's look back here, and now we will just see what are we doing now. Chuk chuk chuk. So let's see how to draw stuff. There is really a lot of things you can do here. As you see, I just want to skip all of those things, essentially, or most of them. Um, but you could really actually write a really decent, like, text editor just by this. I mean, maybe you wouldn't do it in STL, but I think you could. You can really do a lot of things in terms of how the fonts look like, how they are rendered, and so on and so on. But what I want to do is really, I mean, here you see, you can really get crazy. I mean, that's just like, wow, that's kind of ridiculous for me. That's that's for me. I'm not an expert in text rendering, but this kind of looks quite advanced to me. I mean, you can really do a lot of things. However, let's just try to render some text. Render, that looks good. But this is what we want to do. Solid, quick and dirty. That's what we are, and that's what I did, I think. And let's try to render some UTF-8 text or Latin 1 text. I mean, it doesn't really make a difference. Let's stick with the most simple one. Let's say render text solid. Okay, and here we actually have a nice example, and I think I always had to a little bit adapt this when I did it, but let's just see. Okay, let's say let's let's try to do this. So we will actually do all this stuff after we have created a window, I think. So what we need to do is to have a color set up. I mean, there's always plenty of ways to do it. We will just do it like this, and we will just. So I don't know if this is 255 or 1. Let's just stick with, I don't know, 100, 1, 1. No, that's not so good. Let's say 100, 100, 100. That should, in any case, give us a white, I guess. Um, and now we need an STL surface, and the surface needs to be created in a certain way. And this we will look up because I don't remember these kind of things because I am too lazy to remember these kind of things. So we have, I believe we're here. No, oh, it's all there. Surface creation, simple drawing, that's what we want. So we want to create a surface. But actually, I think there is a good example in here, if I remember. Um, yes. Yes, 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 yes. So let's see now. I think I did this in a slightly different way back then. Let's just see. Um, tip, tip, tip. So yeah, okay, no, no, right. This is, yes, it works like this. Okay, so you have the text surface, and then essentially you tell STL-TDF to really render into that surface, and then you just have to. Then there are certain ways to display the to um, to display the to display the text on the screen. And we will come to that. Okay, now let's do that, and let's just initialize it right away as is our style, and then we say just render some text with our font default in our case, and I would just say hello MMO game, and we just give it the color. So if this text surface is null, again, we will just bail out. Printf error while rendering text to surface. Okay, let's see if it builds. It does. Won't see anything, but it basically runs. Okay. Um, okay, so now we have the text in the surface, and then STL surface is, yeah, it's like a back buffer essentially. It's some piece of memory in STL terms where there is stuff, and yeah, this can then be copied to a texture, and then texture can be rendered on the screen essentially. And this is what I wanted to do. This is what I wanted to look up, because essentially you then can say this is our texture, and we call it our texture. That's a funny name. And we will create texture from surface. I think that should work actually. We need the renderer, and we need our text surface. So this should create as a new texture based on the contents of our back buffer surface, sort of. Okay. At that point in time, we can actually free the surface because we no longer need it here. I mean, anyway, we will need to completely restructure this. I'm really just kind of quickly making things up now, just to see if they work, and then we will restructure it, I think, very soon, because it's getting a little bit messy already, as you can see. So when we have that, what we will actually do is really just copy, or what we just need to do is copy the texture to the screen. And there is some things you can do here. So what render copy does essentially, okay, it always needs a specific renderer. You can have more than one. So we'll have our texture. So what do we want to copy? And then you can essentially give it a source rectangle and a target rectangle. And what this means is that the source rectangle is just, yeah, copying stuff from the texture. So you can choose not to copy everything. So you might have a tile map, and you just want to copy, let's say, the first sprite in the upper left corner. If you say null, then it will just copy everything that's in the texture. And if you say null for the target, it will just completely put it into the complete screen. And yeah, let's see how that works, and let's see how that looks. And let's see if we get something on screen, and here we go. And you don't see it, I'm sorry. Okay, it just takes really quite a long time to see it. So what we see here now, there is hello MMO game, hello MMO game, and that's like very, very ugly because that's just totally, totally, totally too big. So we will improve on that now. So let's say we want to have that in the upper left corner in a smaller font. Okay, so how do we do that? We will essentially just pass it an STL rect. We call this the target rect, or actually let's call it rect target, and then we say rect target. I think the x is 0. I think this is how it works. I will look it up if it does not compile. And let's also say, and I think we have the width and the height. And let's say we just make that 100, and we just make that, I don't know, 40. And then what we do is just pass in this rect target here. Well, at least it built, so maybe it wasn't completely wrong. And there we go. I mean, there you see what we have here now is the hello MMO game. Oh, yeah, so now you see it. It's in the upper left corner, so the x is 0. It's actually not very elegant. The y is also 0, and it's 100 long, and then 40 high. So let's improve on that a bit, and let's play a bit around with that. So it seems that this is really a byte value. I mean, I could look it up, but just don't want to now. Let's make it 240. And let's just put that, make that a bit nicer. Yeah, so I mean, it kind of looks like crap, to be honest. But now we can play around with other. So can you see it already? I think you cannot. Yeah, now you can. Yeah, it's really not looking good. So we will play around a bit with that now. Because there is, of course, you need to have a kind of a correspondence between how big the thing is on the screen, like the resulting text here, and like what is the size of the font that you told here. So it might be that like here you say it's 20, and that might just be much too small for this font, or much too big. I mean, we just have to play around. Let's play around with that a bit, and let's say we will just make that as 50. We'll just rebuild everything. And yeah, actually, I mean, so now you see it. It is a bit sharper. Yeah, so this is really, it's really better. But now we can also try, what we can also do now is to just, so what was the name? Funk Rocker, I think it was. Funk Rocker, yes. Let's actually see if that works. Maybe another font works better. Let's see if that works. Might not. Yeah, I mean it works. Also looks not really good. So maybe let's actually try it with a bit of a cleaner font, like where we don't have so many noisy stuff. Let's actually go with computer. Why not? Yeah, that looks. I mean that looks really, and that's free anyway. That's better. That's free. It's called data control. Yeah, that looks nice. So we will again unzip this. We will put it into our folder. So I will just show you that. So here we go. It's called data Latin. I think that's what we will need. So that will be Unicode. I mean, yeah, we will use that probably as well. But just for now, I'll just stick with data Latin. Let's just see how that looks like. And the nice thing, as we have set this up now, that's just a quick change. We can have a look. And yeah, I mean, it doesn't really look nice, to be honest, but better than nothing, I would say. Let's play around with that a bit so that you have that a bit nicer. Okay, I mean, it's not really nice. We could play around with anti-aliasing and stuff, but let's just not do that now. Let's just do a small change. I want to change the color of our background actually. I want to have it a bit less red. Let's just put it like dark gray, like let's say, I don't know, like 10. Let's see how that looks like. So like it's not completely black, but it is. Yeah, gives a better contrast. Okay, let's just pump that up a bit. Okay, good. Well, next thing. Just try that out quickly. Okay, works. Good. Things work, things build, you can see it. Okay, let's move forward. Okay, so we can now do some text rendering. That's something, and I would say the first thing we do for our client is to display the current frames per second. That's always something that's interesting. And for frames per second now, of course, we could get into all kind of, all kind of theory and how to calculate that and do weighted averages over certain frames and so on and so on. And we will eventually do that, but probably not now. Very probably not today. We just want to have something very basic up and running. And before actually I will show frames per seconds, I will just um, just measure the time one frame takes essentially, because that's also an interesting information. So as you know, let's just fire that up. Sorry, which one here? So here we go. Just move all out of the way. We have the duration of a frame. Or let's say that our target frame rate. So we have the target frame per second. Let's say that we want 60 frames per second. That means that each frame only has a maximum duration that it can last. So that's 1 over 16, 1 over 60, sorry. And that's, I don't know, something like 16, but 6, 6, 6, 6, 7, whatever. So we have roughly 16 milliseconds for one frame. So In other words, if we have a target frame rate of 60 and we just say our game client shall run in 60 frames, then each frame is not allowed to take longer than 60 milliseconds. This is really it. That's all. That's all the time we have. That's really all we have. So it's a good it's a good tool. I think it's a good way to right from the start to always kind of have a bookkeeping of what you do in the frames, how long everything takes, um, and we will just do that right away. And we will also kind of display this information directly on the client so that we're always aware, okay, how long does our frame actually take? Um, Good. Let's see. So, how to measure time? There is actually some nice functions in STL2, and now probably is the time that we will create our first helper function, our first helper module, let's say. Well, let's see. I mean, let's see if that is already paying off. Um, let's see. Let's see what we're doing here. There is might be the timer stuff. Yeah, I think actually it's this. What do the ticks give us? Number of milliseconds since the STL library initialization. So it's number of milliseconds. I mean, that's not maybe as accurate as we want to go, because if you think like a millisecond, it's obviously 1,000 of a second. I mean, you only have 16 of those, and that's actually quite rough. So computers are very quick today, obviously, and I'm not a big fan of measuring frame time just in milliseconds because that's actually too coarse grained, I believe. Because if you think about it, if you do things right, you will do quite a lot of things in your game, I believe. And so either the things that you do anyway, they fit like in 1 or 2 milliseconds, and you just don't get a feeling of how long which thing really takes. And then when one thing gets a problem, then you just don't know what it is because it's just a coarse grain, but all of a sudden just a whole bunch of actions just takes too long. Um, yeah, it's just too coarse. I think we should really go down, and let's see. I think we can do that with the performance count and performance frequency functions. Let's see how this works. Yes. So that's just a raw value. I mean, this performance counter, there is actually a native function in Windows, I believe, which really gives you a very high precision timer. That's a timer that's really kind of directly uh, deducted from or taken from some CPU cycle counter. So that's really very quick. That's really in a nanosecond or even below range. And that's really what we want. And I think, yeah, they will just fall down to that anyway. There is a problem with this kind of thing I heard in multi-core computers because there is, or there might be a problem with that timer not being accurate, and not giving the right values across certain cores, because it might be that the operating system runs your program in one moment on one core and in the other moment on a different core. So it might give a problem. I mean, we will see. That's a live event. That's a live stream. We'll just really see it if it works or if it not works, and we'll just do something else. Let's just look at this, and now let's just see what this does. There is even an example that's very nice. So that's the count per second of the high resolution counter. So okay, that gives us actually the number of counts per second that the high resolution counter is is able to do. Let's just find that out. Yeah, let's just see what it can do, and let's just look at that. Um, so essentially, when you know how many times that thing can actually count per second, so like if it would say 1000, then we would know, okay, it actually just has a millisecond resolution. If it says 1 million, okay, I believe then we are in nanosecond range, and so on and so on. So this is like what we will just find out, and then we will see how big the number is here actually. Okay, so let's see. They do all kind of stuff which I'm not interested in. I am actually just really interested in the raw number. They do some timing stuff, which I also don't want to do. I just want to say, yes, that's the performance frequency. Yes, exactly. Okay, good. Let's just see. And we will just kind of like play around with this now. We'll just play around with this kind of right in the beginning. After the initialization, I think that we need to do. Let's just see. Okay, yeah, that's a big number. Obviously, that's a U in 64. That's the ticks per second. And let's initialize them with 0, and then we will. No, I mean stupid. Can right away say STL get performance frequency. And we'll just print that out right away. Ticks per second. And now I'm not completely sure. That might be UD or something. Let's try this. It's just ticks per second. Let's see if that works. Ticks per second. So what is that? 3,410,073. I mean, I'm actually not completely sure. Like printf unsigned long. I mean, that's because I think that's what we're actually doing. Let's just see if that makes a difference. Because I don't want to be tricked into just having it output in the wrong way, and I'm just thinking that's the wrong thing. But that's actually the same thing. Okay, so that seems to be it. So this is the resolution, and by the nature of mathematics, this tells us that we that we can find out the elapsed time by essentially measuring the start and the end time, then deducting, or let's say we know we measure the ticks at the start, we measure the ticks in the end, then we know how many ticks have passed, and then we just need to kind of we just need to transform this raw number of ticks into a time frame, which we can do because we know how many ticks we get in 1 second. Okay, so let's just see. Let's just say that at the start of each frame iteration, because essentially, I mean, in case you didn't notice, but this is our frame loop here. Oops. This is what's happening here. So we have kind of like the classic loop. Essentially, we are checking the inputs, not doing really anything with it now, but we will maybe soon. Then we would like manipulate our model. And then we render our world, all our models, the complete state of the game. I mean, that's what a game is, isn't it? Getting input, applying the input on our game objects and our model, and then just rendering the current state out. Okay, so at the beginning of this loop, so I guess that must be an uint chip. Where do they do this? STL get performance counter, yes. Yeah, okay. So that's the frame start tick, and that's STL get performance counter. And then we have a uint 64. That's the frame end tick. Okay. And then let's just print it out for now. No, it doesn't really matter. Frame start tick. Sorry. Okay, let's just see. At least it builds, starts. And yeah, there in the background. I mean, you see it. No, you don't. Now you see again. Yeah, so each frame, we're really counting ticks. And there you see it really, the ticks, I mean, they are small, but I mean, we get some ticks, okay? So, for example, for this frame here, yeah, so we have, I mean, this is all the same. So we have 8,727 ticks minus, so 38,727, 30,999. So that's around, I don't know, 300, 400 ticks, yeah. Let's just print that out, and let's say the uint64 equals like frame ticks equals and let's just print that out as well. And there we go. Let's collect some data. So you see it's around, yeah, so the last one. So we have around 700 ticks. Okay, so now let's do a bit of mathematics. And let's say, okay, how long does one tick take? Okay, tick take. That sounds good. So we know that one tick Takes, what was it? What was it actually? Haha, do we still have that? No, what was it? I think 3.7 million or something. Ticks in 1 second. Okay, so essentially, okay, how do we do that? I need to bring it up once more. Okay, I need to bring that up once more. So it's essentially 341, 3.4 million. So that's 1 over 3,410,073. That's just a very small number. 60. So just give me a second. Okay, yeah, that's what I want. Just a second. 1 over 3, 4. So I'm using the calculator in the background. That's all I do. And that's really a small number. So that's really, I think that's really in nanoseconds. So that's 2.9 nanoseconds. Let's just look that up. If I'm not mistaken, nanoseconds to seconds. Okay, so maybe it's microseconds. Yeah, okay. So if we have 2.9, 0.29 microseconds. So, okay, that will take a bit of time. I'm really a bad mathematician to know that now. So let's see. We have, let's see how that looks like. The 3,410,073. So we see we get 2.9 to the negative exponential of 2 of 7. So that means, so 1 millisecond is one microsecond is that. So that means it must be, yeah, okay. So that's essentially, if I'm not mistaken, it must be 29 microseconds. So what we get here is actually microseconds. And I think that should work. If I'm completely wrong or stupid, just please let me know in the chat. But let's just work with the assumption that these are microseconds now. Okay, so all that we have to do now is to say, okay, we will multiply, and this is actually just an unsigned int that will not be big. It could even be a char, unsigned int, the frame time, because this is the frame ticks multiplied by 29. and we call this the microsecs by 29 dot, what was that? 29, yeah, I mean, I think that's okay. Well, that's a bit of a weird number, but okay, that's what it is. So now what we will do is frame time microsecs. So just a second. Okay. So let's see now. And we will and this is in microseconds. Okay. Let's try to build the thing. Let's try to run the thing. So what do we see here? This is 33,000 microseconds. That's already quite big. And yeah, let's do one more thing actually, because what we see here is a phenomena that I think I can explain. But let's actually just try something else in between. Um, let's kind of make a cross check. Let's make a cross check and let's see how many ticks we would get here. Because that should be milliseconds. Because if I see here we have, let's say, 12,000 microseconds, that would actually mean that's 12 milliseconds. And let's see if that kind of corresponds. Okay, so we will just do, so that's a smaller number. We will just frame, yeah, just call it the start tick. Get ticks. And tick. STL get ticks. Ticks equals end ticks minus start ticks. And then we'll just have a look at the STL ticks. And we'll also make it like this. And we'll just compare what is the difference. Is there a difference? Is there something wrong? So there's actually something is wrong. I think there's something wrong in my calculation now. Or I mean, really? Let's see. So let's see. We have, let's fire this baby up. Let's see. I mean, that's how things are. So essentially, we have, whoops, we have a tick, like we have a tick at the start. Let's say, I don't know, it's tick 10, and then we have a tick at the end. So that's in the 10th millisecond since the start. And let's say this is in the 11th millisecond. So then we would get one tick. But this is essentially what we see here. This is what we would see here. Okay. So for the performance counter, we also get the tick at the start, which is whatever big number, and then there's also a big number. But here we know that essentially one tick is really like these are the number of milliseconds. Yes, okay. So we know that 1 millisecond has been has passed. So why doesn't that really correspond? Because that's like weird. I mean, look here we see like we have 28,000 macros, but we have zero ticks. Set here we have 11,000 macros. I mean, could be wrong, but anyway, but there we have one tick. I mean, that's just like just doesn't make sense at all. It seems like 60,001, 30,000 takes one, but 22 only takes zero. I mean, that just doesn't make sense. I think I have some issue here. I mean, let's see. Let me think a second. Okay, so I mean, let's see. If I have 11,000, yes, that's essentially what it is. Yeah, I mean, anyway, I'm right. I mean, so I think that's just kind of that's complete nonsense. I think I have to, 'cause what I really have here is, I mean, I think it's actually more along that line. It's actually more a range of microseconds. But what just doesn't make sense is that sometimes I just get a new tick. But that might also actually make sense because that might just be when we are at the border of some ticks. I mean, this is important stuff. That's important to get right. So let's really spend some time. So let's see. How can we do that? So just to be sure. That does make sense. So in the background, sorry, I'm still there. I'm just playing around with the calculator to really get a hang out of it. I'm really a horrible mathematician. I really have to say. Um, I I'm really struggling very often with the basics. I'm really trying to do this now to get a hold of it. So I think I might do that. So there's like one E. Did that work? Yeah, okay. So now we can play around a bit. Um, what we actually have is what is a millisecond? So let's say a millisecond in terms of a second. This is like one. So this is like e exponential minus 3. That should be it. Okay, good. So essentially, if we have something that is e exponent of minus 7, well, that would be microseconds now. Okay, so we have here um, these are the milliseconds and these are essentially the microseconds. So if we have something like this is just a tenth of a microsecond essentially. What we have here. I cannot show it to me. Okay, that's a pity. Okay, that's the last thing he shows me. What? Okay, but I can write it. I think 1, 2, 3, 1, 2, 3, 1. So if I do it like this, yeah, okay. Well, however, so I think that's already it. I mean, we know this is milliseconds. This would be 1 microsecond. So 1 millisecond, 1 microsecond, and 1/10 of a microsecond. Okay. Um, so essentially, what we have is we have just 0.293 microseconds, and that should be it. And that's what I think it should be. And that actually kind of makes sense. Um, it's just still weird why sometimes it just takes, I don't know, it just takes one tick. But let's just see. Maybe we can find that out because as the ticks are so coarse grained, maybe they just fall over. Like there we have the ticks, there we have the start tick, um, and there we have the end tick. And this is essentially just ST and ET. And let's just have a look at how this looks like. So yeah, I mean, it starts to make more sense now because you see here, um, okay, let's look at this here. Okay, but let's maybe start here. Okay, there is one tick and let's start anew. So, so essentially we just made the switch from the 2075 to the 2076. So obviously we have been in the 2075 millisecond tick quite some time. Yeah, we have been quite some time. And then we just switched here. Now we made the jump to 2076. Now we are in that tick, and let's now actually probably try to count. I mean, I don't know if that's really possible to completely be accurate in that way, but let's try it. Um, so we have 152 here with 210 here, so that's 360, that's 490, 490, 500, 520. So, I mean, it's not completely accurate because it would be, I mean, 1,000 of these microseconds should obviously be one millisecond, but probably, very, very probably, this is just not accurate enough. But it will just do. But what you already see, if you base your profiling on the microseconds, I mean, they are much more accurate. So we have 1, 2, 3, 4, 5, 1, 1, 2, 3, 4, 5, 6. Okay, 1, two, three, four, five. Yeah, it's only these five. That's, I don't know, just doesn't really make sense. It's 100, it's 300, 500, 650. Ah, okay, it's not 1000, but whatever. I mean, in the range of microseconds each. Each command takes some time, so that's that's quite possible actually. Okay. Um, so let's really just add just just add now the real frame counter here. So how would you do this? This is not something. This is not dynamic text essentially. So what we had here, what we did here is really just uh, create a surface and create a texture, and well, the surface was created here, and we just rendered one one text, one piece of text into this, and it never changed. And very efficiently, this texture, once it was created, was just copied each frame to the frame buffer essentially, and then displayed. Um, so we have to do this differently now, of course, because this has to be updated. So essentially, more or less, all of that has to happen essentially here. Sorry. Yeah, um, I'm horrible at this. Um, no, that's not what I wanted. Um, okay, I think now that works better. Okay. Ah, what did I do here? The STL event. I think that's not necessary. Yeah, we don't need that here. So we will essentially just write some, write the frame time in here, and yeah, I think that's just a char array, I guess. Frame time text buffer. And let's just make this, I don't know, let's just make it 50 bytes. I mean, that should really be enough. Oh, don't need that. And let's just try something out. Just see if that works. And let's just count 0, and then we will just, yeah, that's actually a model manipulation. We'll just raise the counter, and we will essentially just print this into our counter. So this is the frame time text buffer. Yeah, it's just, I think it works like this, and this is really just this. And this is just the current value of the counter. And there we just say frame text, frame time text buffer. I mean, let's see what comes out. Okay. sprintf. I just need an example. Yeah. Okay. Yeah. Okay. So it's just that's not the secure version. I think there's an sprintfs or something, at least on the Windows that's existing. Okay. We were not using it. So where is that? Number 85. Okay. Here we go. And yeah, I mean that's basically what you want to see. I mean yeah, so now you see it. That's nice. Um, you see we're counting up, and that's already looking like something, yeah, isn't it? That's already something. That's fun. Okay, good. So now we just know that this basically works. We just can remove. We will essentially just remove all of this. Don't need it now. We will yeah, we will need to do oops, bit of a manipulation because we will move these out, these out. Let's clean up a bit already. It's still totally messy, but it doesn't matter. Let's get rid of this. Now we just have the frame ticks. Tick time macros. Okay. Microseconds. Okay. That doesn't exist anymore anyway. Okay, so we will actually move this out of the, I mean, we will not completely move it out. We will just move this out. So we just move this out. We'll just move this up. So it's outside of that inner loop. It's like global towards the render function. We'll just set it up with 0. Doesn't matter. I mean, that changes anyway very quickly. Then we will essentially update that always at the end of the frame. And yeah, essentially what we render is always the frame time of the last frame that has happened. Okay, so we will now just enter the frame time in microsecs, and this we will just enter here. Okay, I mean, let's see if that looks like it's working, because we should get something in the range of 200, 300, 400, 500 microseconds. Okay, let's see. Cha-cha-cha. Yeah, I mean, that's okay. Frame time microseconds, because that must be. Oh, okay, frame time microsecs. That was just. Yeah. I remember I made a small mistake here. I made a small mistake. And that's actually working. So you see, we are in that range, and now we can probably display that in terms of microseconds. So it might actually be looking a bit more stable. So if we say like we have 1000. So we will just add now yeah, let's do that. Let's just write that. Let's do that. Let's say so if we say 1000 divided by, or sorry, divided by 1000, then that should actually give us the value in milliseconds. And of course, that's won't work because we need an unsigned float millis. Let's do it a bit differently. Millis equals 1000 microsecs. Let's see how that looks like. Let's see if that makes sense at all. Okay, so that did not work at all. That crashed completely. I mean, you might not have seen it, but it really crashed. It really, really crashed quite hard. Let's try that again. Okay, I mean, it's not so bad. See, milliseconds are 0, but okay. Something went completely wrong. I don't know why. Let's try this out. What is the problem here? Is that the problem? I mean, I don't think so. That shouldn't be a problem normally. Yep, here we go. Okay, so, but it's like, I mean, does it make sense? Does this make sense if I say that's 1000 by 250? 250 by 1000. Yeah, I mean, I'm just stupid. I am just stupid. I mean, that's of course, whoops, that's of course what I want. And yeah, that's more like it. That's more like it. So, and this is of course completely stupid. Doesn't make sense at all. So, I guess it might even be more a bit nicer to actually see that in milliseconds. Um, oops, and we'll just call this frame time. And now we should actually have some nice stuff, which is not so nice at all. Okay, why is that? It's just okay that. Ah, yeah. Okay, no. It is, of course, it is nice. Frame time is fine. I think all is fine. I just made a stupid mistake. I'm just interested in the millis, and then I just gave him stupid stuff. And now that actually works. I think we need just to make it bigger. That's the way. Yeah, so that's it's basically running. I mean, it just looks completely crappy. Um, let's see what we can do here, actually. What is the problem? I really want to that this looks nice. Oh, look, that looks much nicer already. Um, hope you can see that as well. I mean, that's much crisper, much crisper. So let's try to actually improve something here. I mean, you should not prematurely optimize stuff, but and that will actually be more or less the last thing I think I will do today. Um, let's just see if we can actually reuse our sorry, that was the wrong thing. The surface. If you can reuse the surface. If we can reuse that actually. Um, I think we always have to do that anyway. No, I mean that's really just no. I think we have to completely redo that from scratch. Yep. That just um, I think what we need to do is to actually what's it called? We have to throw away the texture because what we essentially do here is we always create a new texture, and I think we will run out of texture memory soon. Um, we need to free the texture. Free the textures. Fill rect, convert, surface. Nope, maybe it's here. Yep, create texture. Destroy texture. That's the name. Okay. So I mean, essentially, that just doesn't doesn't help us anyway. So let's just keep this. Um, so we destroy the texture, and this is just our text texture. I mean, that should not give any visible difference anyway. Okay. That's how we see. Okay, so we have essentially 1/4 of 1 millisecond, and we have 16 milliseconds. So already with this, we are spending some time already. Okay, and yeah, I would say that's about it for today. So what we did is really, let's maybe go back to our master plan. Let's go back here. So what we want to achieve here is to really write a game from scratch. Obviously, that will take a long time. As you've seen, we just made the very, very first baby steps, but at least from zero, we have something. I mean, let's just maybe start, let it run in the background. Um, we just have we have a working window that is displaying the current frame time. We have a game loop. We have something. So we played around. Essentially, it was not much more than playing around in whoop, in that area here. Sorry. So we have been playing around here uh, in the gameplay client. We really had the very, very first basic version. So yeah, I will take a break. I will think of what we should do next. I'm not quite sure how to best continue. Probably we will either just stay a bit more in the gameplay client. I mean, without having any game really, that it might not be so useful, but we just might spend some time to just render something that's maybe motivating because that we see something, or we might just go back to the back end, to the server, and actually start with some gameplay on the server and actually start developing some network code. That might also be interesting. And then when we have that, continue with the client, or we might just be in the client and just prepare everything to retrieve actual information from the network and to render the information that comes from the network in in the in the packets that we define. And yeah, so what else did we do? I mean, we obviously drew some stuff in 2D, definitely. We had no audio output so far, no networking. Um, got to learn a bit SCL2. We saw some more C, bit of C++. It's not really C++ actually. There is no class, no nothing. Um, I will eventually load up stuff to GitHub that I will do. So we can continue there next time, and then I will just probably put the link to the code in the description. Fun, yeah. Did we have fun? I don't know if you had fun. I mean, I had some fun. It's always fun to start something from scratch, and at least we have something here now. And it's running. It does nothing, but it runs in 60 hertz. It runs in 60 frames per second. I mean, that's something. So far, we're still there. So far, the goal is reached. we're there. We're green. All is good. And yeah, we will always have an eye on that frame time. So when we add more features and when we add communication with the network, we will see that things will take much more time. And yeah, I think of maybe I will just save this thing and I will just maybe really have it as an endless picture here, and we will just continue at the next on the next day. So normally the next stream will go up tomorrow. I will write some announcement on Twitter and on Twitch. I'm not quite sure. It will be somewhere around the morning in Europe, maybe 9, 10 in the morning, I guess. Um, and then we will continue with some of these points. Okay, thanks for joining. Thanks for watching. It's just a start. I hope you had some fun. Maybe you even learned something, maybe just how not to do things. That's also quite possible, but that's also good. And yeah, so thanks a lot and see you next time.